Good morning. Now I am going to take a seminar on cryogenics. Main point to be discussed in this topic are what is cryogenic tech, why uses dewar flux in cryogenic applications, aerospace in cryogenic, history of cryogenic rocket engine, cryogenic grinding, merits and demerits of cryogenic. What is cryogenic technology? The word cryogenic originates from the Greek word cryo, which means cold. Cryogenic is a study of very low temperature. The temperature as low as 180 degree centigrade are attained in a cryogenic system. Cryogenic is a study of low temperature and the behavior of material under this low temperature. The cryogenic process also have a unique capability for recycling difficult to separate composite material. The extremely low temperature are produced by using substances called cryogens, such as liquid nitrogen and liquid helium. Liquid nitrogen are mostly used in the cryogenic. They have a boiling point of below 150 degrees centigrade. Cryogens are stored in the vessels called as dewar flask, which provides the good insulation. The diagram shows the dewar flux. In this, the hot or cold substance is stored under vacuum with the help of silvered surfaces. This liquid nitrogen, the nitrogen gas makes up the major portion of the atmosphere, which is about 78.03% by volume. They are inert, colorless, odorless, non-corrosion, non-flammable liquid. They are extremely cold. Their volume of expansion liquid of gas at 50 degrees centigrade, 1 atom, that is 1 liter of liquid nitrogen evaporated to form 682 liters of nitrogen gas. The applications of the cryogenics are aerospace, cryogenic rocket engine, manufacturing field, medical field, electronics field, and fuels research. The next will say the cryogenic history of cryogenic technology in rocket propulsion. The United States was the first country to develop a cryogenic rocket engine. The RL-10 engine registered its first successful flight in 1963 and is still used on the Atlas V rocket. On April 15, 2010, India launched the communication satellite GSAT-14 into in orbit. The geosynchronous satellite launch vehicle, which is called as GSLV. The diagram shows the India's first cryogenic rocket system. Here, the sum of the liquid nitrogen is utilized in cooling engine. The pressure of the liquid nitrogen is increased from 0.7 megapascal to 2.9 megapascal using turbopumps. Advantages of the cryogenic system are the high energy per unit mass, economical, handling and storage of cryogenic. The disadvantage of the system was the handling and storage of the cryogenic gases can be dangerous, may be expected to be explosion. Next we will see the manufacturing field cryogenic grinding. The problem faced in the conventional grinding process were high heat generation, less tool life, loss of entry coil in spice grinding, oxidation. Next we will see the work of the cryo grinder. The material is to be cleaned manually, fed into the hooper. Liquid nitrogen from the storage containers is sprayed into screw conveyor. The sensor monitors temperature in the conveyor. When the mill is grinding, the material gets crushed between the studs and comes out through an optional sleeve as a ground rod. Top to the bottom of the mill, a collecting bin is housed. The vaporized nitrogen from the mill is sucked by the centrifugal blower and through the filter assembly, and the cyclic process is continued. The next one is the merits and demerits. And merits are lower grinding cost, prevent oxidation, finer particle size, low heat generation. Demerits of the system are high operation cost and high power consumption. Health hazards of the cryogenic liquids are skin and eye hazard and cold embrittlement. Conclusion: cryogenic grinding technique can efficiently grind most of material and can also facilitate cryogenic recycling of tough composite materials. The cryogenic process also has a unique capability for recycling difficult to separate composite materials. Thank you.